You're good. All right, guys, so a few things. I'm sort of surprised when a student asks me, will you be in your office next week? Or do we have class next week? Next week is spring break. You guys with me? Take the week off, sort of. Do some math. Put math and Poco. Next test is Wednesday after spring break. So I'm going to email out the practice test. So you can get started on that if you want to. I'll have hard copies on Monday. And Tuesday will be review day, as always. And if there's anybody out there that needs a makeup test too, call 644-7200 to make an appointment. I'll send the tests over that way. I'm going to email you guys too in case some of you guys are not here to hear them. Any questions on any of that? Any big spring break plans? What's up?
Mostly play around to new trading patterns.
In the what?
Mostly play around to new trading patterns.
Oh, okay. Yes.
Rosarito.
Ah, Rosarito. I haven't been down there. Some friends said it's nice. You been down there before? All right. I was going to go to Arizona, Sedona.
You was? Why aren't you?
Yeah, things have happened.
Dang.
Yeah, I know. But I've been there before. It's way too nice. Yeah. If you believe in solar batteries, it's really get them recharged. There you go. Or this is really nice views from up the top, Cathedral Rocks. Yeah. Okay. So let's get back into mathematics. I think last time we barely stepped into 10.6, which is solving radical equations. So let's remember how to do this. Let's see. By the way, over spring break, I'm going to try to carve aside some time to get a packet for the next chapter after this next test put together for you guys. We'll see if that happens. All right, so what's the first step on this problem here? Yeah, get that radical by itself. I always joke that this is sort of like I'm teaching you how to be a tyrant of a small country. You have a radical element. You isolate the radical element and then you kill it. There's my radical element. I've isolated it. And now I'm going to come in there and kill it. How am I going to kill it? Square it. I do the opposite operation. So over here I get, over there I get 25. I like it. So 4x equals 26, x equals reduce 13 over 2. Is that cool? All right, not too bad, right? No, not too bad, Jeff. All right, what about this one? Let's see. Yeah, I like it. That's yummy. That's just creepy, Jeff.
I like it. That's it.
Okay. I'm only missing 50 people, that's all. You're all smart, you're here. So obviously the first step here is now, even if that negative wasn't here, this would still not be a problem, right? Why? It's an odd root. Odd roots can handle it, but what do I still have to do? Yeah, get the radical by itself. It's not by itself yet. There's this understood -1 in front here, so if I divide by -1, and then what do I do to both sides?
Fifth root. Five to the power thing.
There you go. I like it. Power thingy it. Fifth root, the opposite of that is fifth power. Is everybody with me? You guys cool with this? Okay. Ah, they kill each other. What's 2 to the 5th?
32.
32. You should know a lot of powers of 2. 2 to the 6th is 64. 2 to the 7th is 128. Blah, blah, blah. Especially if you do any computer work, 2 is special. Anyone know why 2 is special for computers? What language yet? Computers use binary language. I'm sure you all heard of that. Zeros and ones. Right? 0 means no voltage, 1 means voltage. So everything you see in a computer is based on, does it see a voltage or not on a certain line? That's it. Zeros and ones. It's crazy. So base 2 means you don't have any number 2, 3, 4, 5, 6, 7, 8. All right, I'll stop. I don't know. What got me? Oh, yeah, powers of 2. And then what do you do here to finish this? Subtract 5. And then divide by 2. Now, I'm not being careful. Here, I don't have to be too careful. If you want to check to see if this is true, you can plug it in. But why do I not really have to worry about plugging in to see if it's okay? Because again, it's an odd root. Over here, technically I should plug that back in to make sure, but I mean I can see right here it wasn't a negative number. Do you guys see that? But still, if I plug that back in to check it, back here on number 1, whoa. Plug that back in, plug 13 over 2 in. I get 2 plus square root of 26 minus 1 equals 7. 2 plus square root of 25 is 5. Check. So you just get used to checking your answers for radicals because there's so many places where they can have a problem. And when I square both sides, I'm losing information about what was negative, what was positive to begin with. That's why there could be wrong answers introduced. Okay, so let me give you one. Totally do on your own here. Let's see. You guys see that's -3 square root? Let's see. Should it be mean? No? Okay. Alright, I won't. I'll do. Let me catch up to you guys. Now, if that wasn't there, what could I do right now? If that wasn't there, what could I say? No solution. Square root cannot equal a negative number because by definition it's the positive root of whatever's inside. But that's there, so what do I do? By negative 3, I get square root of 5 minus 4x equals 1. Square both sides. 5 minus 4x equals 1. And then you subtract 5, divide by negative 4, you get x equals 1. A lot of ones. If you plug 1 back in, 5 minus 4 times 1 is 1, square root of 1 is 1, negative 3 times 1 is negative 3, minus 1 is negative 4. So it does work if you plug it back in. How are we feeling there? Notice how that problem is not different from the one we did before. You isolate the radical element, make sure it makes sense before you continue, and then you kill the root. And then you can solve like a normal chapter 2 equation, way back, 9th, 9th. Alright, so here we go. Here's where things get weird. So we cool with that one? You guys, any questions on that one? Okay. I always like how equations sort of like upside down. Christmas trees. That's all right. Let's see. What about when I introduce? Do not too mean here. Ooh, I gotta make it work. Okay, I got it. Alright, let's see if I made one that works. Ah, good luck. Oh, 1 second now. Make this 5 and 6. Trying to save you from evilness. Self-inflicted evils. Okay, that'll work.
Yay.
It's a 6. Thank you. First thing you do is add 1. How you guys doing so far? Does this agree with what you did here? When you get to this stage here, what do you guys do next? Yeah. Get it equal to 0 first. Now, what would I have to do next? I would have to do 4 times 24, but you guys notice how everything can be divided by 2? I'm going to divide everything by 2. Now I have smaller numbers to worry about, right? Anytime I can make the numbers I have to work with smaller, yes, I will do that. Yep, 8 and 3, they're both negative. Since I'm running out of room, you guys can do all the grouping and stuff. I'm going to show you, let me see if some of you guys can see what I'm doing here. I need an 8, a negative 8, right? Again, do the grouping, right? Rewrite the middle term, group it, beautiful. I just want to show a few of you guys a slightly different way to play with these numbers. If I put a negative 4 here, that gives me a negative 8 here, right? You see negative 8? And I need a negative 3. There you go. And negative 3 times negative 4 is plus 12. Holy shit. Holy shit. Alright. But if you do the grouping and stuff, you should get here. Is that cool? Pretend like that's cool. So I get x equals 4. Or x equals, add 3 divided by 2. Now what I have to do right now, check. Got to check both of those things. So let's check it. If I put a 4 in, I'll get the square root of 8 plus 1, square root of 9 minus 1 equals twice 4 minus 6. I get 3 minus 1 equals 2. Check. Oops, sorry. Right, just plug 4 in, make sure it works. Now if I plug 3/2 in, I'll get 3/2 times 2 is 3, plus 1 is 4, square root of 4 is 2, minus 1. Twice 3/2 is still 3, is 2 minus 1 equal to 3 minus 6? No. So my answer is 4. I have to throw that 3/2 out because it doesn't work. Yes, ma'am.
How did the 8 become a 4?
Oh, you mean here?
Yeah.
Okay. The 8 didn't become a 4. So again, I can do this whole thing, right? Rewrite the middle term. Pull out a 2x. Pull out a negative 3. And end up here. Cool? But the better you are with playing with numbers, the more you can do what I did, which was I need an 8. Well, there's got to be a 2 here, doesn't there? Doesn't there have to be a 2 here? One of these places has a 2, right? So put the 2 there, I put a 4 there, so together they make the 8 I need. It's a really neat way to look at that. Do you have to look at it that way? No, because you got it this way, which is perfectly beautiful. Just showing you a different way to look at it. A little quicker if you're comfortable with numbers. All right, so we got 2 possible answers, but only one of them worked. Why did math do that to us? Because it's mean. No. Because when we squared right here, we lost information about if this was negative or positive. If x is 3/2, this is negative. That's why that led to a bogus answer. here's the ultimate, I won't say ugly problem, but that's what you would think maybe. The ultimate level. All right. My final form. Come on, freezer. Yes.
Are we making,
Wait, ultra what?
we make,
He goes, are we making the ultimate poke ball?
Pokeball?
Yeah. Oh, that's a okay, Pokeball.
There's actually Dragon Ball reference.
Oh.
Sorry.
Nope, not Dragon Ball. Oh, ha, sorry, misinterpretation. Pokemon.
Oh, Pokemon. Oh, sure. Why not? I don't
Oh,
know really
but
Pokemon.
then he does the ball. So
I don't know them
Pokemon,
too well,
Pokeball.
except for the roving hordes of people that don't go out anymore for the Pokemon Go. The Charmander. What the shit is a Charmander? Sounds like Motivator, yeah. You see, whatever floats your boat. All right. You mean now I forgot what I was going to hold. Okay. Ooh, that's yummy. That's so yummy. All right. Let me see if you guys get this. Every problem we did before this had how many radicals in it? If you look back, every equation we did before this with the radicals, they had one radical. How many times did it have to square? Once. It's crazy. This has two radicals. You're eventually going to have to square twice. It's amazing. So the best you could do, if you're a dictator and you got several radical elements and you're like trying to get one alone, you can't get them both alone. You get one of them alone and you kill it. And then you see any more radical elements, get them alone and kill them, right? You're very sensitive. It's too damn bad. Math is violent. So here, look. Do I have a radical element alone? Yes. So then what am I going to do to both sides to kill it? Square. Look at this beautiful side. All right, pick your side. I picked this one. I'm done. You guys do this one. I did my half. Yeah, Jeff, that's funny. I did. It's half the equation.
This is tough.
Oh, yeah. This is nowhere near as gross as it looks. What is the square root of x minus 3 times the square root of x minus 3? X minus 3. Then I get plus one of these, plus another one of these, so I get plus 2 of these. And then I get 1 times 1. That kicks ass. Do you see another radical element? Yes. So get that radical element by itself. So you can square and kill it. So it's really just applying that one process twice. Yeah. So what really nice thing happens with these guys? And then negative 3 plus 1. -2, and then I just have to do a couple things, get the radical by it. Is everybody cool with what just happened? -3 plus 1 is -2. Subtract x from both sides, it's dead. Add 2, and then divide by 2. Whew. And then you can, yes, square both sides. I got my other radical element by themselves. I can squash them and continue my reign of terror. So again, if you didn't understand an earlier problem, I would hope you would ask a question then. So I think I'm going to assume that everybody understands the idea of getting a radical by itself and then squaring both sides. So the beginning of this is nothing different. It's just that when I do that, I still have a radical there. So then any equation that came from anywhere that has a radical in it, what do? Get the radical by itself and then kill it. Doesn't matter that you're in the middle of a, no, it doesn't matter where shit. It doesn't matter that that all happened. I could just give you this problem, and what would you do? Get the radical by itself. Do you see what I'm saying? So you seem to have memory, you're like, no, it came from something, so it's got to be different. No. I could give you this problem, and it didn't come from anywhere. You'd still get the radical by itself. Square both sides. And then add 3. You get 4. It's so nice after all I work. It's like a nice 4. But you better check it. Square root of 4 is 2. Square root of 4 minus 3 is 1. Plus 1 is 2. It works. Yay. And that's how I made that equation. I just started with the answer. So that works. I like it. Okay. So that was a review and finishing up that section 10.6. Now, what I want to do today, I'm getting new stuff now. I'm going to skip 10.7 for the moment. I'm going to leave it for Monday, and we'll see how much I can do in there or not. I want to get to definitely 10.8. We must do 10.8 for sure for this next test and just in general. 10.8 is where we start to look at square root of -1.